Hello and welcome. Today we're going to be talking about section 7.5, which is on scale drawings of figures. Our essential question for the day is, how can you enlarge or reduce a drawing proportionally? In your notes, please go ahead and fill in the blank. A scale drawing is a proportional two-dimensional drawing of an object. All that means is that if I have a drawing, a proportional two-dimensional drawing of it would be the same drawing, just either larger or smaller than the original. Everything would either be doubled or tripled, or maybe cut in half or 1/3, depending on the scale that we use. Similarly, a scale model is a proportional three-dimensional model of an object. This is similar, except that instead of just being a two-dimensional flat drawing, we now have a three-dimensional object that you can pick up, something like a model house or a toy boat or something like that. So the three-dimensional model might be twice as big, 3 times as big as the original, or maybe it's half as big or 1/3 as big as the original object. Our key idea for the day is scale. The measurements in scale drawings and models are proportional to measurements of the actual object. The scale, go ahead and write that in your notes, gives the ratio that compares the measurements of the drawing or model with the actual measurements. For example, underneath the key idea, we have a sample where we're comparing our model with real life. 1 inch represents the distance between 2 points in a drawing, while 10 miles will represent the actual distance between those 2 places in real life. For example, maybe if you drew a map of your city, on your map, on your piece of paper, from school to home might only be 1 inch away, but in real life, if you were to drive from school to home, it would be a distance of 10 miles. You may write your scales as a fraction, or you may also write them as a ratio with a colon, where 1 inch still represents the drawing and 10 miles still represents the actual distance. Go ahead and make sure you filled in your notes, please. Example 1. We want to know what is the actual distance between Cadillac, which is here, and Detroit, which is at the bottom right of the map. Now our scale, they tell us in the top right-hand corner, is that 1 centimeter represents 50 miles. So on the map, if you measure out any 1 centimeter distance, that means in real life, those 2 places are actually 50 miles apart. Well, what I tell you, I've already done the measuring for you, is that on the map, the 2 cities that we want to know have a distance of about 3.5 centimeters. So if my scale is 1 centimeter representing 50 miles, I'm going to go ahead and write that out as a fraction. 1 centimeter represents 50 miles, so the distance on the map is the number on top, and the distance that it actually is on the bottom. I am going to let my scale be equal to what I want to know. Now the cities that I want to know on the map are 3.5, so I put 3.5 on top for the map, and on the bottom I don't know the actual, so I'm going to go ahead and let x represent my actual distance. From here, all we do is cross multiply to solve. X times 1 is x, and on the other side, this equals 50 times 3.5. Multiplying 50 and 3.5, I find that x equals 175. Well, since x represents the actual distance, my final answer would be the actual distance is 175 miles. And this would be your final answer to the question. In On Your Own number 1, I'd like for you to go ahead and find the actual distance between Traverse City and Marquette. If you were to use a centimeter ruler to measure the distance from Traverse City to Marquette, you would find that the distance on the map is about 2 centimeters. So I'd like for you to go ahead and use that value, the exact distance from Marquette to Traverse City. Go ahead and pause the video and try doing that on your own now. To go ahead and check your answers, you should have written a proportion where 1 centimeter on the map represents 50 miles in real life, and that's going to be equal to 2 centimeters on the map, that's the distance we care about, representing x miles in real life because we don't know. When we cross multiply, x times 1 is x, and that's equal to 50 times 2. So x is equal to 50 times 2, which is 100, meaning that the actual distance between those two cities is 100 miles. And that would be your final answer for On Your Own number 1. Example 2. The liquid outer core of the Earth is 2,300 kilometers thick. A scale model of the layers of the Earth has a scale of 1 inch representing 500 kilometers. How thick is the liquid outer core of the model? So our scale is 1 inch on the model, representing 500 kilometers in real life. So my scale factor is going to be 1 for the model in the numerator and 500 for the actual in the denominator. That's going to equal the question that we are talking about. We want to know how thick is the liquid outer core if the model. They tell us at the beginning that the liquid outer core of Earth is 2,300 kilometers thick. This is your actual. So we have the actual, that's going to go on the bottom, but we don't know the model, so I'm going to put an x in the numerator. We cross multiply. 2,300 times 1 is 2,300, is equal to 500 times x, so that's just 500 times x. From here, we'll go ahead and divide by the 500 so that we can get the x by itself. And we'll reduce this fraction as much as possible. X is equal to 2,300 over 500. I can reduce this by dividing the top by 100. I get 23. And the bottom, when I divide by 100, I get 5. So x is equal to 23 over 5. Now I can't reduce this anymore, so what I need to do is see which of my values, A, B, C, or D, is this equivalent to. Since the values in my answer choices are decimals, I'm going to go ahead and divide this. I have 23 inside and 5 outside. 5 goes into 2, not at all. 5 goes into 23 4 times. Subtracting, I get 3. Put decimals and bring down a 0. 5 goes into 30, 6 times exactly, and there is nothing left over. So that tells me that when I did the division, I ended up with 4.6. So x is equal to 4.6. What we just found is the liquid outer core of the model. Well, the model is in inches, so our final answer should be in inches as well, which leaves us with answer choice letter B. The model has a thickness of 4.6 inches. In On Your Own number 2, the mantle of the Earth is 2,900 kilometers thick. How thick is the mantle of the model? I'd like for you to go ahead and use that ratio of 1 inch in the model representing 500 kilometers in real life. Model is in the numerator and actual is in the denominator. That's going to be equal to the scenario that we want to know about. Go ahead and pause the video at this point and complete the rest of the question on your own. The mantle of the Earth is 2,900 kilometers. That is an actual measurement. So that tells me that my denominator is going to be 2,900. We want to know how thick is the mantle of the model. So we do not know the numerator since that represents the model. Now that I have my proportion, I cross multiply. 2,900 times 1 is 2,900. And that's equal to 500 times x. I divide by 500 to isolate x. And I find that x is equal to 2,900 divided by 500. Reducing this fraction, I know that 2,900 divides by 100. I get 29. And 500, when I divide by 100, I get 5. So x is equal to 29 over 5. To get a decimal, I'll go ahead and do some division. 29 inside and 5 outside. 5 goes into 29 5 times. When I subtract, I get 4. Putting decimals, I'll bring down a 0. 5 goes into 48 times exactly. So x is equal to 5.8. And since the model has units in inches, x is equal to 5.8 inches. Or the model has a thickness of 5.8 inches. And this would be your final answer for On Your Own number 2. Okay, that's all I have for you guys today. Thanks so much for watching, and I hope you have an awesome rest of your day.